Hey mathematicians, let's get started with parallel lines and angles, section 3.2. Our essential question, what does it mean when two lines are parallel, intersecting, coincident, or skew? And our objectives are that mathematicians will be able to use properties of parallel lines, prove theorems about parallel lines, and solve real-life problems. Alright, so let's talk about some postulates that we'll need for some future proofs. Alright, so we learned about some angle pairs in the previous lesson. So now, let's take a look at some postulates pertaining to those angle pairs. Here's our first one. Corresponding angles postulate. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Shorten that down to an implied. Parallel lines imply corresponding angles congruent. So if you remember from the previous lesson, corresponding angles, they're the ones that are on the same side of the transversal and then in the same position of the lines. Well, now our lines have special relationship. They're parallel. So when you have parallel lines cut by a transversal, then corresponding angles are congruent. So angle 1 and angle 5 are congruent. And we can say angle 1 is congruent to angle 5. We can say that angle 2 is congruent to angle 6. And we can say that angle 3 is congruent to angle 7. And we can say that angle 4 is congruent to angle 8. These are all pairs of corresponding angles. Next, we have the alternate interior angles postulate. If two parallel lines are cut by a transversal, so this is the same starting hypothesis of the previous postulate, then alternate interior angles are congruent. So shorten it down to our implied, parallel lines implies alternate interior angles congruent. So let's take a look at our pairs of alternate interior angles. Remember, alternate interior angles from the previous lesson are the angles that are on opposite sides of the transversal, so 3 and 6, 4 and 5, and they're on the interior, so that would be in this section, so between the lines. Again, this time our lines have a special relationship. They're parallel. You can see that by our special parallel marks, these little bolded arrows. So if lines are parallel, then alternate interior angles are congruent. So angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. This is our alternate interior angles postulate. Alright, next we have the alternate exterior angles postulate. It states if two parallel lines are cut by a transversal, so this is the repeat hypothesis that we've seen in every postulate so far, so they all start with the same hypothesis. This time the conclusion is that alternate exterior angles are congruent. So shorten that down to implied, parallel lines implies alternate exterior angles congruent. So remember, alternate means on the opposite side of the transversal. Here's our transversal. So angle 1 and angle 8 are on opposite sides. Angle 2 and angle 7 are opposite sides. And then the exterior means to be on the outside of the lines. So these would be on the outside of the lines, and these would be on the outside of the lines. So put that together, we've got alternate exterior 1 and 8, alternate exterior 2 and 7. Therefore, angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Alright, our last postulate for this lesson is the consecutive interior angles postulate. So if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. This is the first time we see a supplementary relationship. All the other previous postulate relationships have been implying congruence of angles. So this is the one pair of angles that are unique. In other words, when you have parallel lines, it implies the consecutive interior angles are supplementary. That means they're going to add up to be 180 degrees. Consecutive, remember, is one after the other on the same side of the transversal. Interior is on the inside of the lines. So 3 and 5 are consecutive interiors, 4 and 6. So we can add the measure of angle 3 to the measure of angle 5, and that will equal 180 degrees. We can also add the measure of angle 4 to the measure of angle 6, and that equals 180 degrees. This is our consecutive interior angles postulate. All right, so let's take a look at a few examples. Let's just start with example 1, identifying angles. All right, so the measures of 3 of the numbered angles are 120 degrees. Identify the angles, explain your reasoning. All right, so angles that are equal to 120 degrees. So we've got this angle that we start with, and then we just identify other angles to help us figure out the missing angle measurements. All right, so we can identify measure of angle 4 to be 120 degrees. Why? Well, let's take a look. Angle 4 is directly across from 120 degrees. Notice they're a part of the same intersection. So when you have lines that intersect, angles that are across from each other are vertical angles. So the reason measure of angle 4 is equal to the given 120 degrees is because vertical angles imply equal measured angles. All right, next we can look at measure of angle 5 is also 120 degrees. And the reason that measure of angle 5 is 120 degrees is because parallel lines, which we know these are parallel because of our special markings indicating that these lines are parallel, cut by a transversal. So if you have parallel lines, it always implies corresponding angles congruent. So when you have corresponding angles congruent, that makes measure of angle 5. So 120 degrees is corresponding to angle 5, making it congruent. We also have measure of angle 8 is 120 degrees, and that's because you have alternate exterior angles. For any of the parallel lines cut by a transversal, it implies alternate exterior angles congruent. And I just noticed that my congruent symbols were missing at the end of my implied statement, so I added those in. So we have proper notation here for our implieds. So those are all the angles that have a 120 degree measurement. All right, example 2, using properties of parallel lines, find the value of x. All right, so we look at our situation. We've got parallel lines. We know that by our indication of our blocked arrows that are matching on these two lines. Therefore, these lines are parallel. We have a transversal cutting right through those two lines that are parallel. We know this angle to be 115 degrees. We know this to be the angle 4, so this is the name of the angle. And this angle has an expression x plus 5 degrees. So we can look at our initial relationship between 115 degrees and see that the measure of angle 4, since it is equal to 150, it is vertical angles with the given 115 degrees, we can conclude that measure of angle 4 is also equal to 115 degrees. So again, when lines intersect and they share the same intersection, angles that share the same intersection and are across from each other are vertical angles. And vertical angles are always going to be equal measure. So our next conclusion is that 115 plus x plus 5 equals 180, and that's because parallel lines implies consecutive interior angles are supplementary. So since consecutive angles are, interior angles are supplementary, we can set up our equation 115, so that's this angle, plus the x plus 5. And that's because since these are equal, 4 is consecutive interior with this angle here. So we can substitute the 115 for the 4, and then angle 4, and then plus the x plus 5, and set it equal to 180. Combine like terms, so 115 plus 5 is 120, so 120 plus x equals 180. Continuing to solve for x, subtract 120 from both sides, and so x equals 60. And I just realized that I left off the supplementary typed in here, so it should be consecutive interior angles supplementary. All right, next let's look at example 3 using properties of parallel lines. Find the value of x. All right, so we've got two parallel lines, a pair of parallel lines cut by a transversal. So that makes angle 1 and the expression 7x plus 9 degrees. So this angle congruent because they're alternate exterior angles. We also can see that we have consecutive exterior angles, which we haven't really talked about, but that is an option. And we have a linear pair. So anytime you have two angles, adjacent angles sharing opposite rays, straight angle, that's going to be supplementary, a linear pair. So we've got some options here to kind of consider. So let's take a look. Alright, so since we have a linear pair, we have measure of angle 1 adding up to 136 degrees, totaling 180 degrees because they're supplementary. So we can solve for x. Solve for the measure of angle 1. Subtracting 136 from both sides. Resulting in the measure of angle 1 equaling 44 degrees. So now that we know that angle measure, we can next set up an equation, measure of angle 1 equals 7x plus 9. And that's because they're alternate exterior angles. So parallel lines implies alternate exterior angles congruent. So that means that they are equal in measure. So now we can substitute measure of angle 1 with 44 degrees and solve for x. So for x, subtract 9 from both sides, so 44 minus 9 is 35, and then divide both sides by 7, resulting in x equaling 5. So you're simply using properties of parallel lines to solve for unknown values of x. All right, let's take a look at this weird looking shape. Definitely have parallel sides, and that's indicated by the markings, and then we have two edges that meet at a right angle. And then anytime you have parallel lines, you can always extend the sides of any shape to reveal parallel lines cut by a transversal in this case. So here we have parallel lines cut by this edge or transversal. So you can always extend edges to see the lines. So that makes angle 6y and 3y consecutive interior angles. And we know that consecutive interior angles are supplementary. So that allows us to say 3y plus 6y equals 180 degrees. So combine like terms, so 3y plus 6y equals 9y equals 180. Divide both sides by 9, so y equals 20. So next we can conclude that parallel lines implies consecutive interior angles supplementary. So this is the reason why we were able to set up the original equation of 3y plus 6y equals 180. All right, so now we can set up the 2x plus 3y equals 180 degrees. Substitute the 20 for y, resulting in 2x plus 60 equals 180. Subtract 60 from both sides, so 2x equals 120. Divide by 2, so x equals 60. And the reason we were able to set up this equation for 2x and 3y equaling 180, so this angle and this angle, are because in a quadrilateral, which this appears to be a quadrilateral, consecutive angles are supplementary. All right, so I leave you with these pondering if-then statements, conditional statements. And that's all for this lesson. Bring your clarifying questions tomorrow and be ready to practice. See you in class.